In this section, we will move to one of the important topics in Python, which is files. So far, we were using the console, this black or white screen that just mainly consists of text. We used to call it console, and we used to read and write from it. The I/O stream from keyboard, mainly we use the input function and the print function. In practice, we need to save our data in hard disk, not just in the memory, because once the machine is closed or the application is closed, everything is gone. So typically we need to save data to hard disk, and this is where comes the files to read and write to them. We call that streaming, either streaming to the console or streaming to files. It's more about an indication to movements of data from some source here, like reading, to some source here, maybe writing, and so on. So the word stream is very common, mainly some bytes moving from somewhere to another. The files mainly can be used to store the data, and typically you are using files all the time. The data.txt, an image, an executable, all of them are data. In industry, files aren't the right way to handle most of the problems. There is something advanced called databases. Databases is more about, again, kind of files that are very efficient to put data and to query the data. So every time we say the word database, you might think of it like just some complicated file system, something that allow us to put data and get data from it. In the future, you should learn about things like RDBMS or NoSQL and so on. But for now, let's focus on the files, because it is your first step to understand that. In this session, I will be providing no codes. We will be mainly learning about a bunch of things related to the files in general. Every file is mainly three parts: header, data, and EOF. You typically know about the data part. When you open a text file, you can see the content. But there are actually two other things. What we call a header, which is a metadata. The word metadata is very common in computer science. It is like a data about the data. So it's like extra data about something. Here, for example, we need the file name, its type, and so on. The end of file is a very special character that is marking the end of a file, which is something very important for something reading from the file to recognize that we are done with reading. The second concern about the content itself, the files can be either binary files or text files. The text files are like the files that you are opening all the time and writing text. Someone asked you to write a mobile number. You open a notepad file and wrote their mobile number and saved it. This is typically like readable characters. The binary file is something that is encoded with a low-level bytes. And a byte is something that's very low level for the system, mainly consisting of zeros and ones. If you try to open a binary file, it would look like very, very weird like that, something that isn't readable. Many of the files that you are using are actually binary files. If you open an image, the image is a binary file. The executable is a binary file, and so on. There are a lot of binary files around you that already you are using. So what is the difference between both of them? The text files normally are natural text, something that you can read. If you played with some letters in a text file, the text file will not be corrupted. You still can open it. And you can even with your eyes spot where are the mistakes or the problems. But one issue with the text file that their file size is growing bigger. And also another concern, the file size vary based on the platform. So from a platform to another, like Windows, Linux, specific versions, the file size itself might vary. On the other side, the binary files, you can write in it the text file. You can write very, very, very binary things. And one of the issues with it, if you did any minor corruption to the file, you probably will fail to open it. Like for example, open your image, open any image, and try to access the content and remove maybe a few digits from it, a few cells from it. You probably will not be able to open the image again, especially if you did that from the top of the file. The file size is typically smaller, and I guess typically it will be the same from a platform to another, at least most of the time. Another concern is about the file name and file path. Every file should have a name, and the name is usually followed by some extension. If you have something like customer info.txt, then customer info is the file name and .txt is the extension, or you can consider all of it like a file name. Something like data.tar.gz, also that .tar.gz is the whole extension. If the file name is just data, then this file doesn't have an extension. The other thing is the directory or folder. It's where the files exist, and you have a lot of folders or directories on your system. Any path might be full or relative. A full path is something that is starting from the root of the system to the file. If you are in a Unix system, it can be something like // something. Guys in Windows will have the double backslash, and this might be a concern. Like any programming language will try to make as much as it could things in a way that allow multiple systems. Like we don't have to write something for Windows and something for Linux. We need something that's more platform independent. And there is also what we call a relative path. Relative path is something relative to the current location. Like let's say, for example, let's say we are in the directory /home/Mustafa. Then this file, for example, if we wrote something like workspace/myfile.txt, this is a relative path. It isn't starting from the root. It is starting from where we are starting here, the Mustafa. You can also write /. Dot here is referring to the current directory. And remember, in the module system, we learned about the dot and dot. So the dot is actually referring to the current. So it's like current/workspaces. In our code, we typically refer to relative paths, not to full path, because remember that your code will be moved to another machine. So it cannot be like hard coding something in your file about where exactly a file exists. So it can be something like data/some file, but it will never be a complete path. About the dot and dot, you are supposed to know about that. Dot refers to the current directory. Dot refers to the parent directory. Let's say, for example, you read some path like that, code / blah blah blah, and then we have here dot / something. Every dot / means go one up layer and cancel me. So for example, here if you have dot, then it means actually go and cancel this one. So we can remove the z with this dot. Now this path, again, we have dot. If you can also cancel that one, and now it will be directly code blah blah blah. Be careful with paths that have spaces. They usually cause problems. If you are writing command lines, you typically need to use double quotes before and after to avoid problems. Another concern is line endings. Line endings isn't a bit straightforward due to some historical reasons. Regardless of that, moving between an operating system to another still might be a problem, especially between Windows and Linux, because there are differences. Sometimes when you take a file from Linux and move it to Windows and you open it, you will feel like maybe the whole file is in the same line of code. This is mainly because what we call line endings. We have two things, what we call carriage return, /r here is an escape character, or line feed, lf, or the \n. We use the \n a lot through the course in writing and the printing. In Windows, the ending of the files are typically /r/n. So Windows files recognize an end of the line using /r/n. But in Unix and newer Mac machines, we use only the \n. As you see, there is some differences here, which that's why you might be, for example, notice differences in viewing some files between Windows and Unix. The last thing is the character encoding. Character encoding is our way to represent the different characters. There are too many characters of too many different languages, like saying Russian language, for example, Chinese. There are a lot of symbols. So in terms of programming, we have ways to represent this kind of characters, and typically there is some kind of numbers attached to the characters. There is what we call an ASCII encoding system. ASCII represents mainly 128 characters. So this is mainly representing a small set of characters, like the character from A to Z small and characters from A to Z uppercase, the digits from 0 to 9, symbols like the @ and the hash and the not, all of these nice symbols. So overall they are around 128. This is very common, and this is what you write most of the time in your files. However, we have too many human languages, and they have a lot of characters, and we have also math symbols. So to do that, we need something that expresses more characters. This is where the word Unicode coming. There are two versions of Unicode. Unicode UTF-8, which is very popular, and UTF-16. And UTF-16 is very huge, covering a lot, but in practice, UTF-8 still is the most popular because it is already covering too much. One more information is, if you try to open a file with the lower encoding capabilities, you will face a problem. For example, let's say a file is written with a lot of math equations and a lot of symbols from Russian language. If you try to open it with ASCII encoding, it will fail because ASCII recognizes only 128 characters. It varies from a programming language to another. For example, in Python, the default encoding is platform dependent, so be careful about that. Generally speaking, if you would like to open a file with a specific encoding, you should open it. Like if you would like to open a file with UTF-8 encoding, open it with UTF-8 encoding. This is an example of a UTF file content. As you see, I'm putting here for you a very wide mix of characters. Like I'm not sure, I think maybe German language has this kind of characters. The first line here has a lot of mathematical symbols, and we have here some symbols, I think, from chemistry. And then we have a bunch of languages that I don't know most of them, probably some of them from Russia and some of them from Malaysia, and many other things. The moral of that is we need something to represent this huge set of characters, and the ASCII only represent our normal English letters and digits, which are only 128 in maximum. But we need something to represent something much bigger, and we need still to express this kind of symbols. That's why behind the scene, every letter that you see here has some ID. Like let's say the UTF-8 encoding, I forgot the number. Let's say it's covering 500,000 different symbols. So maybe this symbol is number 0, this 1, this 2, this 3, this one is 4, this one is 5, 6, and so on. And then the computer, when it sees the digits, the symbol, the digit like 0, it can tell back the corresponding character. Another thing I would like you to know, if you try to create a file and save it, probably in Windows or Linux, you can observe some notes here. Like you notice the character encoding here, the default is UTF-8. You also observe the line ending. There are drop menus here that allow you to make much more than that. I know that this video has a lot of information and all of them are theoretical, and I expect that you get like 50% of them at the moment. Do not repeat the video, keep going, come back to it maybe later. The more you go in the career, you will recognize this kind of information. I just wanted to collect all of them for you in a single video so that they be like a future reference for you. And when you listen from me to some of the relevant keywords, come back and refresh it. That's all.